To finish off example 9.2.1, what we are looking at is it appropriate to conduct inference for the model and to explain? So what we want to do is go back and look at the couple plots that we saw on the previous page and comment on what we're seeing. First of all, if we look at the scatter plot, we had a few things to look for. Does it look linear? Yes, that's true. Are there any obvious outliers? No, they're not. And then is the variability the same as we move left to right? This one may have a little fanning out if we kind of draw along here, where maybe there's more spread at small pH values and less spread at large pH values. So there might be a slight issue there with that constant variance assumption. The other thing was that the residuals needed to look normal. We used a histogram in an earlier example. This one we have a normal probability plot, and we do see this deviation from the line up here. So that is suggesting that those are probably not normal looking. So our answer is that we are probably seeing some conditions here being violated. So probably not a good idea to be conducting inference for this model. Regardless of our answer there, we're asked in part C to look at an F-test to find out if a linear model is appropriate. We already filled out the rest of the ANOVA table in part A. So our F-test statistic and our p-value are provided here, and those are checking if the linear model is effective or ineffective. Okay, so if we jot down all the info for this test here in part C, our null, just in words, is that the linear model is ineffective. So not effective. Our alternative is that the linear model is effective. So you could kind of think of this like, is the slope 0 or not kind of thing. F is the 25.251, p-value approximately 0. And so here we would reject the null and say that we have significant evidence that the linear model is effective or appropriate. So it turns out that either doing this sort of test for a linear model where we check the F or doing the t-test for the slope are equivalent. And that is because if you take the t-test statistic, which if you want to look at the previous page, we can get that from the output. It is this number down here, negative 5.024. If you take that t-test statistic and you square it, negative 5.024, if you square that number, you will get back 25.241, which there's a little off for rounding, but that is essentially equal to our F value. So the t-test for slope and the test here of whether or not the linear model is appropriate or effective are equivalent, because if you take t and square it, you do get back the value of F, and so they will always produce the same p-value from their respective t and F distributions.